Hello students, how are you? In my previous video, I have discussed concepts related to exercise 3.1. Hope you are able to solve the questions from exercise 3.1. If you have not done yet, do check my video from the link given below. Today I will discuss the concepts related to exercise 3.2. Now to start with, let us first understand how can find the different trigonometric ratios. For that, we are to consider a circle of a unit radius with its center at the origin of the coordinate axis. And we are to consider point AB that moves along the circle in anti-clockwise direction. Let this point covers an arc of length x. Now join OP so that the angle AOP is equal to x radians, that is equal to length of the arc AP upon the radius of circle OP, that is x upon 1 is equal to x. Now from P, draw PM perpendicular to OA so that OPM becomes a right angle triangle. From this we can calculate all the 6 trigonometric ratios, that is cos x is equal to base upon hypotenuse, that is OM upon OP is equal to A. Similarly sin x, which is equal to perpendicular upon hypotenuse, that is equal to B upon 1 is equal to B. Sec x, which is equal to hypotenuse upon base, that is 1 by A, and condition is that A should not be equal to 0, or you can say sec x is equal to 1 by cos x. Similarly, cosec x is equal to hypotenuse upon perpendicular, that is 1 by B, and condition is B should not be equal to 0, or we can say it is equal to 1 by sin x. Next we move to tan x. Tan x is perpendicular upon base, that is B by A, and again the condition is A should not be equal to 0, and B is equal to sin x, A is equal to cos x. So tan x is also equal to sin x by cos x. Similarly, cot x is equal to base upon perpendicular, that is A by B, and condition is B should not be equal to 0. So A means cos x, B means sin x, that is cot x is equal to cos x upon sin x. How you have understood how I calculated these trigonometric ratios. Now let us understand how can we write the trigonometric identities. For that, let us consider OPM is a right angle triangle. Applying Pythagoras, we get OP square is equal to OM square plus PM square. So OM is equal to A, or we can say A is equal to cos x. So A square means cos square x. Similarly, B means sin square x. So cos square x plus sin square x is equal to 1. This is the first identity that we have studied in class 10. Now we take this equation and divide the whole equation by cos square x. So we get 1 plus sin square x upon cos square x is equal to 1 upon cos square x. Or we can write like this way, 1 plus sin x by cos x is equal to tan x. So 1 plus tan square x is equal to 1 by cos square x means 1 sec square x. So identity will be 1 plus tan square x is equal to sec square x. This is the second identity that I have studied in class 10. Now again taking the same equation, that is equation number 1, we divide this equation by sin square x. So we get the answer cos square x upon sin square x plus 1 is equal to 1 by sin square x. Cos by sin is equal to cot x. So cot square x plus 1 by sin means cosec square x is equal to cosec square x. So these are three identities that we have studied in class 10, that is cos square x plus sin square x is equal to 1, 1 plus tan square x is equal to sec square x, cot square x plus 1 is equal to cosec square x. Let us now understand how we can write the signs of trigonometric functions. For that, consider 2 points P and Q. P lies in the first quadrant and Q lies in the fourth quadrant, so that the angle AOP is equal to x and angle AOQ is equal to minus x. If we calculate the value of cos of minus x, it will be equal to OM by OQ, which is again equal to OM by OP. Because OQ is equal to OP is equal to radius of the circle, hence it is equal to cos x. Similarly, if we write the value sin of minus x, it will equal to MQ upon OQ, which is equal to minus MP upon OP, and it is equal to minus sin x. In this way, we can calculate the signs of the different trigonometric ratios, or we can understand when the value of angle x lies between 0 to pi by 2, that is in first quadrant, both x and y coordinate of point P will be positive, and in second quadrant, that is from pi by 2 to pi, the A means x coordinate will be negative and y means B will be positive. And in third quadrant, that is from pi to 3 pi by 2, both x and y coordinates, that is both A and B, are negative. Similarly, in the last quadrant, that is in fourth quadrant, 3 pi by 2 to 2 pi, x will be positive, or we can say A will be positive and B will be negative. Let us now understand how we can calculate the values of different trigonometric functions. For that, we are to understand the moment of point P, along the circumference of circle in anti-clockwise direction. Let us start from the point A. When the point P is at A, the angle x is equal to 0 and value of A, that is x coordinate, will be 1, and value P, that is y coordinate of point P, will be 0. So as angle x is 0, so we will calculate the different trigonometric ratios for angle 0, that is cos 0 is equal to A and is equal to 1. Sin 0 is equal to B, so it will be equal to 0. Similarly, sec 0 is equal to 1 by A is equal to 1 upon 1 is equal to 1. Cosec 0 is equal to 1 by B, that is 1 by 0 is equal to infinity. Tan 0 will be equal to B by A is equal to 0. Similarly, cot 0 is equal to A by B is equal to infinity, that is 0 upon 1 upon 0 will be infinity. Now, when the point P moves to point B, that is P coincides with B, the angle x will become pi by 2, that is 90 degree, and coordinate of P, that is x coordinate, will be 0 and y coordinate, that is B, will be equal to 1. So we will calculate the again trigonometric ratios for angle pi by 2. So cos pi by 2 will be 0, sin pi by 2 will be 1, sec pi by 2 will be infinity, cosec pi by 2 will be 1, tan pi by 2 will be infinity, and cot pi by 2 will be 0. Now this point P move from point B to C, so that angle x becomes equal to pi, and x coordinate of point P, that is A, is equal to -1, B is equal to 0. So we can calculate the trigonometric ratios for angle pi. It will be like this way: cos pi will be equal to -1, sin pi is equal to 0, sec pi is equal to -1, cosec pi is equal to infinity, and tan pi is equal to 0, and cot pi is equal to again infinity. Now from the point P, from the point C, the point P moves to the D. Again, the angle will become x is equal to 3 pi by 2. X coordinate of P, that is A, will be 0. Y coordinate of point P, that is B, will equal to -1. And we get these values. Cos 3 pi by 2 is equal to 0. Sin 3 pi by 2 is equal to -1. Sec 3 pi by 2 is equal to infinity. Cosec 3 pi by 2 is equal to -1. Tan 3 pi by 2 is equal to infinity. Cot 3 pi by 2 is equal to 0. And lastly, from D point, point B, P again goes back to A, completing the whole circle, that is an angle of 2 pi, that is x is equal to 2 pi, A is equal to 1, B is equal to 0. Again, this value will be same as the cos 0. So values will be cos 2 pi is equal to 1, sin 2 pi is equal to 0, sec 2 pi is equal to 1, cosec 2 pi is equal to infinity, tan 2 pi is equal to 0, cot 2 pi is equal to infinity. Hope you have understood this concept nicely and clearly. Let us now understand how these values repeat itself. You can see from the table that sine and cos repeat themselves after an interval of 2 pi. That is sine 0 and cos 0 both have same value as sine 2 pi and cos 2 pi. That is sine 0 and sine 2 pi is equal to 0. Similarly, cos 0 and cos 2 pi is equal to 1. But the tan and the cot repeat their values after an interval of pi. That is tan 0 is equal to 0 and tan pi is also 0. Similarly, cot 0 is infinity and cot pi is also infinity. Hope you have understood how the values get repeated themselves. This table indicates how the different functions, that is trigonometric functions, increases or decreases in a particular quadrant. Let us start with the sine. Sin x, that is sine and cosec. Cosec is 1 upon sin x. So they will follow the same rule but in opposite direction. That is, if sine will increase, the cosec will decrease. You can see from the table that sine increases in first quadrant and the fourth quadrant, and decreases in second and third quadrant. Same way, cosec will decrease in first and last quadrant but increase in second and third quadrant. Now we move to the cos x. Cos will decrease in first and second quadrant and increase in third and fourth quadrant. Similarly, sec, which is just 1 by cos, it will increase in first and second quadrant and decrease in third and fourth quadrant. Similarly, tan will increase in all the fourth quadrant, that is in first one from 0 to infinity, in second minus infinity to 0. Here it means infinity to minus infinity, this function remains undefined. So similarly, again 0 to infinity and again minus infinity to 0. Cot will follow the same rule but in opposite direction, that is it will decrease. Again infinity to 0 in first quadrant, 0 to minus infinity in second quadrant, infinity to 0 in third quadrant, and last quadrant 0 to minus infinity. Hope you have understood these functions nicely. This is a simple way to learn the signs of different trigonometric functions. Just draw the coordinate axis, write the line, add sugar to coffee. Add means all the 6 trigonometric functions will be positive in the first quadrant, and sugar means S. S stands for sine. and sine and cosec will be positive in the second quadrant, remaining all will be negative. Similarly, in third quadrant, T means tan and cot will be positive and remaining all will be negative. In the last quadrant, C means cos and its opposite sec, both will be positive and remaining will be negative. Let us now understand the domain and range of different trigonometric functions. Let us first start with sin x. The domain of sin x, that is value of x, belongs to R, that is set of all real numbers, and its range will be -1 to 1. Similarly, cos x, its domain is R and its range is -1 to 1. Cosec x, well, that is 1 by sine, has domain which lies in R except value when x is not equal to n pi, and its range will be R minus 1 comma 1. Excluding this number, all numbers of R will be the range of cosec x. Same way sec x, which is opposite of cos x, so its domain will be set of real number except when x is not equal to 2n plus 1 pi by 2, and again range will R minus 1 comma 1. Tan x again belongs to all real numbers except 2n plus 1 pi by 2, and its range is R. Cot again all real numbers except when x is not equal to n pi, and range is R. Hope you have understood this domain and range concept clearly. To understand the concepts of trigonometric functions more clearly, let us solve some questions. The first question is, let us first read the statement of the question, and the statement is, find the values of other trigonometric functions when sin x is equal to 3 by 5 and x lies in the second quadrant. Let us start with the answer. Since sin x is equal to 3 by 5, so cosec x will be equal to 1 by sin x will be equal to 5 by 3. So using the identity cos square x plus sin square x is equal to 1. So cos square x will be equal to 1 minus sin square x. Hence, putting the value of sin x, that is 3 by 5, we get the value of cos x equal to plus minus 4 by 5. Now, since x lies in the second quadrant, and in second quadrant cos is negative, so cos x will be equal to minus 4 by 5. Now sec x is always equal to 1 by cos x, so it will be equal to minus 5 by 4. Now we move to the tan x, which is equal to sin x by cos x, so it will be equal to minus 3 by 4. Similarly, cot x will be equal to 1 by tan x, and it will be equal to minus 4 by 3. Hope you have understood these questions nicely and clearly. Now we move to the next question. We have to find the values of cot minus 15 pi by 4 and cosec minus 1410. Let us start the first part, that's cot minus 15 pi by 4. We know that cot x repeats itself after interval of pi, so we'll change this number by adding the 4 pi. Cot minus 15 pi by 4 plus 4 pi is equal to pi by 4. We have added 4 pi because cot will remain cot. If we add the value multiple of pi by 2, it will change to the tan x. So we add the 4 pi, we get the answer pi by 4, and cot pi by 4 value is 1. Similarly, cosec minus 1410, and cosec repeats itself after interval of 2 pi. So we will add multiple of 2 pi, that is 1440, that is 4 pi will add here, and we get the cosec 30, and value of cosec 30 is 2. Hope you are able to understand the concepts of trigonometric functions as well as some of the questions which I have solved nicely, and are able to solve some questions from the exercise 3.2. If you face any problem or have any doubt, do write in the comment sections. Do not forget to subscribe my channel for regular updates. Do share my video with your friends and classmates. Till then, goodbye, thank you, have a nice day.